Hi, everybody. Welcome to this edition of the Extreme Performance Series video blogs. With me today, I have a vMotion peer, Sree, who needs no introduction, but we'll let him introduce himself right away, who's, if we check in on the past, all kinds of amazing vMotion information to share. And so, Sree, why don't you give yourself a quick introduction here before we jump into today?
I've been working on vMotion, which is live migration of virtual machines, right, for last several years. But today, the focus is not going to be live migration because by and large, customers are super happy with vMotion performance. But so I would like to just change, the topic just a little bit and talk about a different layer of migration, which is code migration, because that's another pain point that customers have. So I would like to talk about that in today's video.
Sree, lead on for us. What do you have for us today?
Okay, the problem is this, right? Today, migration of a VM which is in a pod of state is extremely slow. Okay, to give you a perspective, if you have a VM with, let's say, a terabyte of storage, it takes more than 2 hours to migrate this VM to a remote host, which is extremely painful for customers. And that's a pain point that we want to address today.
And so how did you do that? How did the two worlds cross over here?
So during the live migration, right, we migrate the entire state of the virtual machine, which is the disk as well as CPU state and memory state, right? In a pod of state, we only are going to migrate the storage. There's no CPU state and there's no memory state. And historically, we always used a different transport, which we'll talk about, because we wanted to migrate this cold VM in a very lightweight manner. But it turns out that when we have a huge amount of storage, the lightweight mechanism that we were relying on is no longer sufficient. We needed to do something more, and that's the focus of today's topic. I wanted to kind of quickly also tell you what we do today, right? Because since the migration is so slow, we when the customers approach us, what we tell them is just pour on the VM. When they pour on the VM, when they migrate this, same VM with the same storage, it's 10 times faster. And when the customers ask us why it is, it's because we use different transport protocols. Like as I explained to you, right? When the VM is in powered on state, we use a vMotion transport. And when the VM is powered off, we use a transport mechanism called network file copy. Okay, both are transport protocols which run on the top of TCP/IP, but while NFC is designed to be very lightweight, vMotion is really designed and highly optimized for transport of a lot of data. And what we're doing today is in vSphere 8, we're introducing unified data transport. The idea of this is we want to instead of having so many different transport mechanisms, we'll have a single transport which is going to transfer both cold and hot data.
Perfect. So I think you're starting with a demo for us. Is that right?
Yeah. And if you see my screen here, I have a data center with a single cluster, which has 3 hosts. And I have just one VM and test VM. And you can see that it's in a pod of state. And currently it's hosted on 170 host. And it's on the local data store. And I would like to migrate this VM to a different host. Let's migrate it. So we're going to migrate the entire state of the both compute resource and the storage. And let's select a different host, 1702. Okay. And let's pick a different local data store. And the first thing you'll notice is there is a warning here. What this warning is telling us is this migration will be using a network file copy, which is less efficient, which is what we're trying to demo, right? So let's start the migration. And let's see what happens. And you can see that the relocate virtual machine task is in progress. And also I wanted to show you one more thing here. Okay, this is a source host, right? And you can see that it has one NIC, which is 25 Gbps NIC, right? And now let's, and I also have a SSH console to the source host. And here, what we're doing is we're going to monitor the network traffic. Okay, and we see it's a VMNIC2, right? And this VMNIC2 is 25 Gbps link. But what you'll notice here is we're only using about just 1 Gbps bandwidth, even though the network itself has 25 Gbps bandwidth. Clearly, it's pretty inefficient. And to understand this, let's also take a quick look at the CPU screen. This network file copy is done by the hostd process. And you'll see that hostd process has several worker processes, right? They all belong to the hostd process. And even though it has several workers, you'll see that there's only one single worker thread which is doing all the work, right? It's just, and one more thing you'll notice is its runtime is very, very low. It just has 16%. Which the reason it's so low runtime is because it's doing a synchronous IO. Okay, now if you see the relocate task is still in progress. Now let's just recap what we noticed, right? Network file copy is very, very slow. The reason is because it uses a user level hostd process to do the copy, which is single threaded, and also this single threaded process is doing IO synchronously, because of which the peak throughput is limited to just about 1.3 Gbps. And as we all know, vMotion is highly optimized. It's multi-threaded and it runs in a kernel context. And it also does IO asynchronously. And if you have a really powerful source and destination data stores, vMotion can even reach the throughput as high as 80 Gbps. And to do that, so now what we're going to do is, let's, again, I want to talk about the unified data transport. What we're going to do is, we want to leverage vMotion as much as possible. So we want to keep the control channel, no changes to the control channel, but instead we only want to offload all the data transfers to the vMotion protocol. Okay, the architecture diagram here kind of explains this in a better way. Whenever there's a cold data that needs to be migrated, vCenter always invokes NFC manager copy. Okay, and NFC manager looks for two conditions. It will first check if the source ESX and the destination ESX support UDT. And the second check it will do is if there is any provisioning network configured between the source and destination ESX source. If these two conditions are met, that's when the UDT comes into play. Okay, and also as I mentioned before, in UDT we are not making any changes to the control channel, and you'll see that the control channel, which is still going to be maintained by the hostd processes which are running in the user space, but all the data transfers are offloaded to the migrate module, which manage the encrypted data channel, and which, as you know, is highly efficient and highly optimized, and we've been optimizing that for over a decade now. Okay, and now just let's switch to the let's switch to the performance demo and see how the performance looks like with these new optimizations. Now, if you go to the VC, you'll see that relocate VM task was finished, and it took us nearly 185 seconds. It started 119 and it finished at 123:14, right? So it took us nearly more than 3 minutes. Okay, now let's now migrate the same VM here again. What we're going to do is we're going to enable the provision network, which enables the UDT comes into play. Okay, so let's just go and add the provisioning network here. So you can add the provisioning network to a different VM connect here, but we're using the same VM connect because we want to use the same VM NIC. Once again, let's say add the provision network on the on both the hosts. So you can see we added the provisioning network on both. Now let's migrate the same VM to the original host. And again, we are choosing the local data store. And you'll see that we are no longer seeing the warning because we are using the provisioning network. So that means this migration will be using the vMotion data transport to transfer the cold data. And now let's start the migration. Okay. And you can see the relocate virtual machine task is in progress. Okay, now let's just switch to the network screen. Here we are seeing the receive traffic. You can see almost we are now hitting 7 Gbps and 6 Gbps. As you can see, it's a ESX top by default, refreshes the screen every 5 seconds. But in general, you'll see the throughput is pretty high. Now, also let's look at the CPU screen. And you can see no longer the host D process running. All the work is being done by the vMotion destination process, which is running in the kernel context, right? So, and I can see the relocate task is already finished, and it just took us just 30 seconds.
See, that's an amazing difference, Sri. I mean, for something that people don't often think about, for people that recognize, that's been a painful process in the past. I mean, this is a very significant optimization to go ahead and use the vMotion transport for that. I mean, that is it went from more than 3 minutes to 30 seconds.
Yes, and if you have a faster storage, it will even be even faster. So at this point, the performance is only determined by the throughput that your source and destination data stores can support. Earlier, we were bottlenecked by 1 Gbps, right? Now, only we can even go 80 Gbps, But in this, we have an NVMe data stores. That's the reason we are seeing 5x improvement.
Amazing.
Yes. So one more thing I want to address here is how do we leverage UDT? It's pretty simple. As long as the both source and destination ESX hosts support UDT, which is the vSphere 8 or beyond, then you can use UDT. And if for whatever reason you choose not to use UDT, you can always, we also have a choice for you to disable UDT. We don't expect you to, but there's a choice available. And what we've seen in the demo today is migration of a cold VM, right? But this feature UDT can be used for transferring any cold data, and cold data is transferred in many scenarios, not only for the cold relocation, which is what we just saw in the demo, but also for a cloning operation where we create a full clone on a remote host. That's when again we're going to use NFC, and that's going to be super fast. And similarly, if you're migrating if you're vMotioning a VM which has a snapshots, that means those snapshots, which are the cold data, used to be will be migrated through NFC, which again will be very fast when we're using UDT.
Great, because we're starting to see a lot of bandwidth available to these hosts. We're starting to see very large VMs, lots of data, stores behind them. Everybody's loved vMotion, like you said, highly optimized, highly proven, and now to be able to just kind of leverage those together, I think that's an awesome addition to vSphere 8. And so we're very excited. Thank you for having shared with that today, all of the new opportunity our customers have with it.
Thank you. Yeah, I really hope customers will see a great benefit from this.
Awesome. Well, thank you, Sri, for joining us today. Look forward to seeing everybody back again on the next edition of the Extreme Performance Series video blogs.
Thanks, Mark.